Hello and welcome back to this channel once again. In today's video, we are going to learn how to find the inverse of a 2x2 matrix as well as a 3x3 matrix. So now let's start off with a 2x2 matrix. Let's consider the matrix A, which is a 2x2 matrix and has elements A, B, C, D. Now, how do we find the inverse of A? Now, the inverse of A, which is normally written as A inverse, is equal to 1 over the determinant of A times the matrix. We are going to interchange the elements in the leading diagonal. So AD becomes DA. And then we negate the other elements of the other diagonal. So that is negative B, negative C. So this is how to find the inverse of A, or better still, the inverse of a 2x2 matrix. Now let's try some examples. Let's assume that we have matrix P to be equal to 2, 3, negative 9, 11, and then matrix Q also to be equal to negative 3, negative 2, negative 1, 6. Now let's try to find the inverse of these 2x2 matrices, that is matrix P and matrix Q. So the inverse of matrix P, which is written as P inverse, is equal to 1 over the determinant of P times. Now let's interchange the positions of these two values. So that's going to be 11, 2, and then we negate these two values. So negative 9 becomes 9, 3 becomes negative 3. Now before we even continue, let's try to find the determinant of P. So to find the determinant of P, we basically multiply these two values. That is 2 times 11 is 22 minus, let's multiply these two values, 3 times negative 9, which is negative 27. Now let's simplify. So we have 22 plus 27, and then adding these two values, you are going to get 49. Therefore, we have the determinant of P to be 49. So coming back to this, we have P inverse equals 1 over 49 times the matrix 11, negative 3, 9, 2. Now let's try to multiply 1 over 49 across. So 1 over 49 times 11 is 11 over 49. 1 over 49 times negative 3, that gives negative 3 over 49. 1 over 49 times 9 is 9 over 49, and then 1 over 49 times 2 also gives 2 over 49. So this is the inverse of the matrix P. Now let's do same for Q. We want to find the inverse of the matrix Q. So first of all, let's find the determinant of Q. So we have the determinant of Q equals, we multiply these two values, negative 3 and 6, and then we have negative 18 minus negative 2 times negative 1, that is 2. So that becomes negative 20. So the inverse of Q is equal to 1 over the determinant of Q, which is negative 20, times, we interchange the positions of these two values. So negative 3, 6 becomes 6, negative 3. And then we negate the other two values. Negative 1 becomes 1. And then negative 2 becomes 2. Now let's simplify. 2 goes into 6 3 times. 2 goes into 20 10 times. So negative 1 over 10 times 3, that gives negative 3 over 10. 2 goes into itself once. 2 goes into 20 10 times. So we have negative 1 over 10 times 1, which is negative 1 over 10. Negative 1 over 20 times 1 gives negative 1 over 20. And then negative 1 over 20 times negative 3 gives 3 over 20. Therefore, we have this to be the inverse of Q. So basically, this is how to find the inverse of a 2x2 matrix. Now let's move on as we learn how to find the inverse of a 3x3 matrix. So how do we find the inverse of a 3x3 matrix? So let's assume that we have a matrix A, which is a 3x3 matrix and contains elements 2, 0, 3, 4, 1, 6, 5, 8, 2. How do we find the inverse of this 3x3 matrix? Now, to find the inverse of this 3x3 matrix, the first thing we are going to do is to find the minus of this matrix. Now, this minus can be obtained by removing or cancelling out the ith row and the jth column of each of the elements in the matrix, and then find the determinant of the resulting 2x2 matrix. So what we are trying to say is that let's assume you want to find the minor 1, 1. So what you are going to do is you are going to select the first value in the first row and in the first column, and then you cancel out the row and column that contains this value, and then you try to find the determinant of the resulting 2x2 matrix. Now that is going to be the minor M11. So basically this is how to find the minor M11, and because we have 9 elements in here, we are going to do same for all the 9 elements. So let's find the minus of this matrix. So for M11, which is the first value in row 1 and the first value in column 1. So selecting this value, we are going to cancel out the row and column containing this value, and we find the determinant of the resulting 2x2 matrix. So cancelling out row 1, column 1, we are left with 1, 6, 8, 2. So to find the determinant, we multiply 1 by 2, and that is 2, minus 8 by 6, that is 48. And then 2 minus 48 is equal to negative 46. So that is the minor M11. Now let's do same for M12. So selecting this value and then cancelling out the row and the column containing that value, we are left with 4, 6, 5, 2. So we multiply 4 by 2, and that's 8, minus 5 by 6, that is 30, and then 8 minus 30 is negative 22. Now to M13, we select this value, we cancel out the row and column, we are left with 4, 1, 5, 8. 4 times 8 is 32. 5 times 1 is 5. 32 minus 5 is 27. Now to M21. So that is 4. We cancel out the row and column. We are left with 0382. So 2 times 0, that is 0. And then 8 times 3 is 24. So we have negative 24. For M22, we select 1. That is the second element in row 2 and the second element in column 2. And then we are left with 2352. So 2 times 2 is 4. 5 times 3 is 15. 4 minus 15 is negative 11. To M23, that is the element in row 2, column 3, and that is this value. We cancel out the row and column. We are left with 2058. So 2 times 8, that is 16. And then 5 times 0 is 0. So we have 16. Now let's move on to M31. That is the element in row 3, column 1. So we have 6 times 0, which is 0. And then 1 times 3, which is 3. So that becomes 0 minus 3. And that is negative 3. M32. We are left with 2346. So 2 times 6 is 12. And then 4 times 3 is also 12. So we have 12 minus 12. And that is equal to 0. For M33, we are left with 2041. So 1 times 2 is 2. 4 times 0 is 0. So 2 minus 0, and that is equal to 2. So these are the values of the minus of this matrix. And let's put that, or let's represent that in the matrix form. So we have negative 46, negative 22, 27, negative 24, negative 11, 16, negative 3, 0, 2. Now after finding the minus of the matrix, the next thing we are going to do is to find the cofactors. Now even before we find the cofactors, let's find the determinant of this matrix. That is the determinant of A. So to find the determinant of A, we are going to select the first element in the first row and in the first column, and we try to find the determinant of the resulting 2 by 2 matrix, and then we multiply that value by 2. So that becomes 2 times. Now the determinant of this 2 by 2 matrix is what we had here as negative 46. So that is 2 times 1 is 2, and then minus 8 times 6, which is 48. Therefore 2 minus 48 is negative 46. So let's put that here. Now the polarity alternates, so it's going to be plus minus plus. So for this value we have plus 2 and then minus 0. So we select 0, we cancel out the row and column containing 0, and then we find the determinant of the resulting matrix, and that is what we had here as negative 22. So we put that here, and then plus. So this is plus, minus, and then plus again. So plus 3 times 27. So 2 times negative 46 is negative 92, and then this goes to 0, and then 3 times 27 is 81. Therefore, negative 92 plus 81 is equal to negative 11, and that is the determinant of matrix A. So we are going to use this later in our solution. It is very important to find the determinant of matrix A. Now let's move on as we find the cofactors of matrix A. Now to find the cofactors that is C, I, J is giving us negative 1 exponent I plus J times the minor ij. Now what this primarily means is that if you want to find the cofactors or the cofactor C11, then it means that this is equal to negative 1 exponent. Now I is 1 here, and then j is also 1. So 1 plus 1 is 2. So 2 times m11. Now m11 is what we had as negative 46. So times negative 46, and then multiplying these two, that is negative 1 exponent 2 is 1, and then 1 times negative 46 is negative 46. So you have C11 to be equal to negative 46. Let's find, or let's solve for C12. So that also becomes negative 1 exponent 1 plus 2 is 3 times m12, and then that is negative 22. So negative 1 cubed is negative 1 times negative 22. Negative negative becomes positive. You have 22. Now there's a simpler way in finding the cofactors from the minors. Now what we are going to do is we are going to alternate the polarity. That is, we are going to have plus, minus, plus, minus, plus, minus, and then plus, minus, plus. So basically this is what we are going to use to generate the cofactors from the minors instead of solving for C11, C12, and so on and so forth. So let's try to use that approach. So to find the cofactors of A, we say that cofactors of A is equal to, now from the minors, we are going to first of all multiply 1 by this value, that is negative 46, and then negative 1 by negative 22, and then we have positive 22, and then this time plus 1 times 27 minus 1 times negative 24, that is 24, plus 1 times negative 11, that is negative 11, minus 1 times 16, negative 16, plus 1 times negative 3, minus 1 times 0, that is 0, and then plus 1 times 2, that is 2. So basically this is the cofactors of A. Now after finding the cofactors of A, the inverse of A is giving us 1 over the determinant of A times the adjoint of A. Now the adjoint of A is also a matrix, and we can obtain that from the cofactors. The adjoint of A is nothing but the transpose of the cofactors of A. So from this we say that A inverse is equal to 1 over, we have the value of the determinant to be negative 11. So we multiply that by the transpose of the cofactors. Now to find the transpose of a matrix, rows become columns and then columns become rows. So we have row 1 becoming column 1. So that is negative 46, 22, and then 27. We also have row 2 becoming column 2. So that becomes 24, negative 11, negative 16. And then row 3 also becomes column 3. So negative 3, 0, 2. So this is the adjoint of A. Now let's try to multiply negative 1 over 11 across to obtain the inverse of A. So A inverse is equal to negative 1 over 11 times negative 46 is 46 divided by 11. Negative 1 over 11 times 24 gives negative 24 over 11. Negative 1 over 11 times negative 3 becomes 3 over 11. Negative 1 over 11 times 22 becomes negative 2. Negative 1 over 11 times negative 11 becomes 1. Negative 1 over 11 times 0 becomes 0. Negative 1 over 11 times 27 becomes negative 27 over 11. Negative 1 over 11 times negative 16 becomes 16 over 11. And negative 1 over 11 times 2 becomes negative 2 over 11. So this is the inverse of matrix A.